Assalamualaikum. I am Fatihah Munida with matrix number S48852. In this video, I will explain about a semiconductor which is a p-type silicon. But first, let's figure out what is a conductor and what is an insulator, and what about a semiconductor. Conductor is any material that allow electric current to flow freely, while insulator is a total opposite of a conductor. Insulator does not allow electrical energy to pass them. Semiconductor is somewhere in between conductor and insulator, as its name implies. Semiconductor is a material that conducts current but only partly. A pure semiconductor, also known as intrinsic semiconductor. Now, when a small amount of travelling impurity is added to the pure silicon, the resulting semiconductor crystal is called p-type silicon. P-type silicon is an extrinsic semiconductor that obtained by doping trivalent impurity atoms or elements from group 13 such as boron, gallium, aluminium, and indium to the pure silicon. At absolute zero temperature, an intrinsic semiconductor can be a perfect insulator as the bond between electrons is very strong, but if heat is applied, the heat energy can break the covalent bond creating holes known as acceptor. As you can see, the figure shows that the doping pure silicon at certain temperature with a group 13 element results in a new empty level between valence and the conduction band of the host. This caused the band gap to decrease and the electrical conductivity to increase dramatically. A p-type semiconductor is produced by a method called doping, and the impurity added is called dopants. When a small amount of trivalent impurity, for example boron, is doped into silicon lattice, boron has only 3 outer electrons in its valence shell. When mixed into silicon lattice, they form holes in the lattice where silicon electron has nothing to bond to, and the absence of electron creates the effect of a positive charge, therefore called as a p-type silicon, and hence they conduct current. Now, what about the application? Of course, it is widely used in the manufacture of electronic components such as resistor, capacitor, inductor, diodes, transistor, and many more. During the manufacturing of silicon-based products, there can be some potential hazards caused during the production stage. Example, to produce the ultra-pure silicon, silica sand need to be melted in electric arc furnace at over 1900 degrees Celsius. The inhalation of silica can lead to chronic, accelerated, or acute silicosis and associated with bronchitis and tuberculosis. Some studies also indicate an association with lung cancer. Exposure to silicon dust may also occur. There are also possible for employee to expose to hydrogen gas in the presence of a copper-containing catalyst to form trichlorosilane, which can irritate and corrosive to the eyes, skin, and mucous membranes. Exposure to high concentration can also cause laryngitis, bronchitis, and pulmonary edema. However, all this potential hazard can be reduced or avoided by performing an appropriate exposure evaluations, proper ventilation, use respiratory protection, and many more. The most important thing is to strictly apply the precaution step and follow the standard operating procedure during the production stage. That's all for today's video. Thank you for watching. Bye bye.